Okay, 5.5, we're going to be talking about performing function operations. So we're going to be given two functions, and we're going to be asked to add them, subtract, multiply, and divide. So when adding functions, the question could either be written like this, where it just says f plus g of x, or it could be written like this, where it's f of x plus g of x. These mean the same thing. If you see the plus sign, you're just adding your two functions together. When subtracting, you always have to be careful because if you have anything more than just one term after it, you'll have to distribute the negative to whatever you're subtracting. Same with multiplying. If you're multiplying more than one term, you may have to distribute or FOIL depending on what it is. And then we're also going to be dividing. And then in addition to finding all of our operations, we're going to be asked to find the domain of the function. So the domains of the sum, difference, product, and quotient functions consist of the x values that are in the domain of both f and g. So we have to check the domain of both of our functions. And then in addition, the domain of the quotient does not include the x values for which the denominator g of x is equal to 0, because we can't have 0 in the denominator of a fraction. So when we check the domain, we just always have to set the denominator not equal to 0 to figure out what additional value is not in the domain. When we check our domains, there's two things we want to look out for. If we have a square root, what can we not have under the square root? Negative numbers. So we can't have negatives under the square root. So to find the domain, when we're given a square root, we would just set whatever's under the radical greater than or equal to 0, because it just can't be a negative number. It can't be less than 0. So to figure out what our domain is, if we had a radical, we would set what's under it greater than or equal to 0. What about if I had an odd index, like the cubed root of -8? Could I do this? Yeah. So if it's an odd index, then we don't have to worry about that. Only when it's an even index, we have to check the restriction on our domain. So when it's an even index, we just have to make sure whatever's under the radical is greater than or equal to 0. And then also, if we have a fraction, so if I had 1 over x, we have to check our domain here because our denominator cannot be 0. So we can't have the denominator equal to 0. So these are two restrictions that we always have to check for when we're finding the domain, if we have a radical or if we have a fraction. Anything other than that, our domain's going to be all real numbers. So example 1. It says let f of x be equal to 3 square root x and g of x is equal to -10 square root x. It's asking us to find f plus g of x. So we're adding our functions. Then we have to state the domain and evaluate the sum when x is equal to 4. So let's do one thing at a time. We're going to find f plus g of x. So we're just adding our two functions together. Take f of x, so 3 square root x, plus g of x, which is -10 square root x. Can I add these together? I have the same variable part, so I can add them together. How would I add? Just combine the coefficients. So what's 3 plus negative 10? Negative 7, and the variable part stays the same. So negative 7 square root x. Next, we want to find the domain. So I have to find the domain of both my functions. I'm going to find the domain for f of x, and then I'm going to find the domain for g of x. And the domain of my f plus g of x is what's going to be overlapping from those two domains. So I'm going to draw a number line here to help see what overlaps. Looking at my f of x, what can I not have here? What could I not plug into x? If it's a square root, what can we not have? Negatives. So my domain is going to be, we would just set x greater than or equal to 0. So x could be greater than or equal to 0. So all the numbers bigger than 0. Now we're going to do the same thing with g. So I take what's under my radical and set it greater than or equal to 0. Because again, we can't have negatives if we have a square root. So it's just going to be numbers greater than or equal to 0. So our domain for f plus g of x is just going to be the overlapping part. So where these two lines overlap, that's my domain. So they overlap from 0 and they go to infinity. Remember, the infinity sign gets a parentheses always. 0's included in both of them, so 0 gets a bracket. So the bracket means that it's included. Infinity always gets parentheses. The domain of our overall function, the f plus g, is the overlapping part. All right, last thing this question asks for is to evaluate the sum when x is equal to 4. So I'm going to take my new function here and plug in 4 into x. So f plus g of 4, because I'm plugging in 4 into x, is equal to my new function here, so negative 7 square root 4. So I just plug in 4 into the x. And then we have to simplify from here. What's the square root of 4? 2. So this would be negative 7 times 2. What's negative 7 times 2? Negative 14. So this question had 3 parts. We had to find f plus g, we had to find the domain, and we had to find when x is equal to 4. So these are our 3 answers here. All right, let's look at example 2. What is it asking me to do to the two functions here? Subtract. It says f minus g of x. So f minus g. I take my function f. I'm going to start with that one. So 3x cubed minus 2x squared plus 5 minus function g. So the second one I'm going to put in parentheses because I'm going to have to distribute that negative to everything behind it. So I'm subtracting the whole function g. So minus x cubed minus 3x squared plus 4x minus 2. Now what do I have to do next? Distribute the negative to everything behind it. And then what am I going to have to do? Combine like terms. Awesome. So I distribute the negative to everything behind, so all the signs flip, and then we can combine our like terms. What's 3x cubed minus x cubed? 2x cubed. What about negative 2x squared plus 3x squared? X squared. And I just have a negative 4x. And then my constant. So 5 plus 2. What's 5 plus 2? 7. So plus 7. So this is my f minus g of x. Now let's find the domain. So for my domain, if it helps, draw a number line. Do I have any restrictions for x in my first function, in f of x? Is there anything that I can't plug into x? Remember, we only have restrictions when we have a square root or when we have a fraction. Do I have either one of those in f of x? No. So this is going to be all real numbers, from negative infinity to infinity. Let's check g of x. Do I have any restrictions there? Do I have any square roots? Do I have any fractions? Nope. So this again is all real numbers. So the whole number line there. So for our domain, we think of the overlap. What overlaps here? They're both all real numbers. What's my domain of f minus g? All real numbers. So we could say ARN, all real numbers. Or you could say from negative infinity to infinity. Any one of these would work. Or you could also say the R with the 2 lines. So that's also all real numbers. All right, last part of this question asks for when x is equal to negative 2. So I'm going to take negative 2 and plug it into all of my x's. So I have f minus g of negative 2 is equal to 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. What's negative 2 cubed? Negative 2 times negative 2 times negative 2? Negative 8. And negative 8 times 2? Be negative 16. What's negative 2 squared? Positive 4. Because it's negative 2 times negative 2, which would be a positive. What's negative 4 times negative 2? 8, and then plus 7. So now we can add negative 16 plus 4 would be negative 12. Negative 12 plus 8 would be negative 4, and negative 4 plus 7, 3. So my f minus g of negative 2 is 3. Right, example 3. We have to multiply, so f times g of x. Then we have to state the domain and evaluate the product when x is equal to 9. So 3 parts to this question. First, we have to find f times g of x. So we're going to multiply our 2 functions together. I have x squared times the square root of x. I combine these together? What do we think? If we have the same base, then we combine them. So I have the square root of x. What's technically my exponent there? Square root of x, the second one. What would my exponent be? X to the power of 1/2 is the same thing as saying square root. So when my bases are the same, what do I do to the exponents to combine? Add them. So this would be x to the power of 2 plus 1/2. So we did this on the test on Friday. How do I add fractions? Common denominator. So I'm going to change 2 to be 2 over 1. How can I make 2 over 1 have a denominator of 2? Multiply the top and the bottom by 2. So I'm going to change it to 4 over 2. Now what do I do to add them? Add the numerators. So I get 5 over 2. So f times g of x is equal to x to the power of 5/2. Now let's find the domain. So the domain we're going to find one at a time. I'm going to draw my number line because I care about where they overlap. So the number line just helps me see where these two domains overlap. So looking at my first function, x squared, what's my domain there? All real numbers. I don't have a square root with the x squared. I don't have a fraction with the x squared, so it would be all real numbers. So everything on the number line. Yeah. Now let's look at the square root of x. What's my domain for the square root of x? Well, what can I not plug into x? Negative numbers. So I would just set whatever's under the square root x greater than or equal to 0. So it's going to include 0 and going to be everything greater than. So looking at my number line, I care where these two lines overlap, the orange one and the light blue one. So what would my domain of f times g of x be, where they overlap? What would this be? Awesome. 0, infinity. Because the orange line doesn't include the negative numbers, so it has to start at 0 and goes to infinity. So my domain would be 0, infinity. It's where our two domains overlap. All right, last part of this question asks us to find when x is equal to 9. So I'm going to plug in 9 into my function. So I have f times g of 9 would be equal to 9 to the 5/2 power. How can I find what 9 to the 5/2 power is? What's my index? 2. So this is the index. That goes out front. So it'd be the square root of 9. And the 5 is my exponent. The number on top stays on top. What's the square root of 9? 3. So it'd be 3 to the 5th power. What's 3 to the 5th power? So this would be 243. Yeah, because this question's asking you to do like 3 different things. So this is technically like 3 different questions in one. It's asking you to multiply them together, find the domain, and find when x is equal to that number. On the next one, it gives us 2 functions, asks us to add them, subtract them, state the domain of each, and then find what f plus g of 8 is and f minus g of 8 is. So this is like 6 questions. So let's start with adding them. So f plus g of x. So I'm just going to add f and g together. So negative 2x to the 2/3 power plus 7 times x to the 2/3 power. Can I add these two together? Yeah, how do I add them? Combine the coefficients. So what's negative 2 plus 7? 5. And the variable part stays the same. So 5 times x to the 2/3 power. I'm going to find the domains last. Let's find f plus g of 8 now. So I need to plug in 8 into x. So I have 5 times 8 to the 2/3 power. So I need to evaluate what that 8 to the 2/3 power is. So what's my index? The index is 3, so that goes out front. The number up top stays on top. It stays as my exponent. So I have 5 times the cubed root of 8 squared. What's the cubed root of 8? 2. If you want, write it out. I have 2 times 2 times 2. Circle your group. 2 comes out. So it's 2 squared. According to PEMDAS, what do I have to do next? The exponent. 2 squared would be 4. And 5 times 4? 20. So f plus g of 8 is 20. All right, let's subtract them now. So I'm going to find f minus g of x. So I have negative 2x to the 2/3 power minus 7x to the 2/3 power. What do I get when I subtract them? Negative 9x to the 2/3 power. Perfect. Next, let's evaluate when x is equal to 8. So it's asking for f minus g of 8. So the question could be written this way, or it could be written like we saw in the last couple examples where it said x is equal to 8. These mean the same thing. It's just asking us to plug in 8 into our x. So we're going to plug in 8. So I have negative 9 times 8 to the 2/3 power. How can I evaluate what 8 to the 2/3 power is? Make my index, which is what? 3. The denominator is the index. That goes out front. The number up top stays up top as our exponent. What is the cubed root of 8? 2. Just did it in the last one. Then I have 2 squared, which is 4. And negative 9 times 4? Negative 36. Perfect. So when we subtract f minus g, we get negative 36. Last part of this question is to find the domain of each. So let's find the domain. So remember, the domain, we're looking at the overlap. I'm going to draw my number line. And then let's look at each function. So with my first function, I I have negative 2x to the 2/3 power. So technically, this is a radical here. What's my index? 3. So this is negative 2, the cubed root of x squared. Now, if I have the cubed root, can I have negative numbers under the cubed root? Yes. If it's an odd index, you can. So what do you think my domain for my function here would be? All real numbers. So it could be any number on the number line. Let's check the same for g. So here I have 7 times x to the 2/3 power. My denominator is the same, which means my index is going to be the same. So 7 times the cubed root of x squared. When I have the cubed root, can I have negative numbers under the cubed root? Yes. So what's my domain on G? All real numbers. So here, for the pink line and the green line, what overlaps? All real numbers. So my domain would be all real numbers. Now it doesn't matter if you are adding or subtracting them, because for adding or subtracting, you just have to check the domain of both of them, see what overlaps. So the domain of both is going to be the same when we're adding or subtracting. So our domain for each adding and subtracting is all real numbers.